Good morning, everyone. Thanks, Uri and the rest of MDLI team. So happy to take the next minutes and share with you the latest updates on and what NVIDIA is doing to help progress the AI community, the AI ecosystem. So I believe that large language models and generative AI will be repeated during the day and everywhere. And actually, the latest progress with the transformer architecture allowed to build modern architectures for multiple AI tasks like image generation, text generation, recommendation systems, and other AI tasks. We see also many research papers on that topic, on large language models and transformer architectures. And we at NVIDIA prepared ourselves in the last 10 years actually to that moment, from the hardware perspective, from the software, from the tools, and the relevant accelerator libraries. So we see new techniques for training those new models, and we can see a few things. One, that the larger the model, the better the accuracy and generalization that we can get from large language models. And we also see new techniques for improving the accuracy of those models, allow us to learn from multiple examples, in most cases not too many, and the model improved. So we see techniques like prompt learning, p-tuning, RLHF, and other new techniques to improve the models. But the basic idea is that we can train a foundation model and then adapt that model to multiple domains. So we recently announced a Hopper architecture, and the new GPU architecture H100 that was released recently represent a big step on computing improvement, up to 6x. We have more streaming multiprocessors. It's a new chip design, 4 nanometer. We have a new Tensor Core, a new NVLink technology, which is 50% faster for GPU to GPU communication, a faster HBM memory, 3 terabytes per second. And all those technologies allow us to train transformer and specifically LLMs much faster than in the previous architectures like Ampere. So one of the leading technologies, we call it transformer engine. Basically, during the training process, we are running a statistical algorithm that allows to manage the dynamic range of FP16 and FP8. And the combination of those two precisions allow us to train the model much faster. This is totally transparent to the deep learning framework. Users, data scientists can enable or disable. And the ability to monitor the tensor statistics allow us to dynamically adjust the range. And that's a huge improvement that is necessary for large language models training. So one of the tools for training and inferencing large language models is Nemo Megatron. Nemo Megatron is a full stack solution that allows us to run on a large GPU system, and then we provide multiple tools for distributed data processing, hyperparameter tuning, distributed training, which is needed for those large models that you will probably need tens or hundreds or even thousands of GPUs that runs concurrently for training the large language model. And we also developed a solution for inference, accelerate inference. It's a new library called Faster Transformer, which NVIDIA developed using CUDA to optimize the inference on a multiple GPU, multi-node, that in some cases is needed to infer those large language models. So we provide linear scaling to thousands of GPUs, to trillion parameter language models. It's much faster than previous architecture, and as I mentioned, it's not only for training, but it's also for inferencing. So we are using Triton inference server with a faster transformer backend to serve those large language models in low latency and high throughput. So one of the latest announcements is beyond the Nemo Megatron that is in open early access. So data scientists, developers can download Nemo Megatron for training and for inferencing those models. But we also announced a new service. We call it NVIDIA Nemo LLM Cloud Service, where basically we are at NVIDIA training many community models in different sizes. This is what we call foundation models, and we even train a 530 billion parameter model. Then companies, developers can use their own domain prompt to customize the LLM. And once the LLM is customized to the need and to the specific domain, like biology or chemistry or speech or any other domain that we want to customize the model, then we can get the customized model, and we can serve it in two ways. One, we can download the optimized model in a container and run it everywhere, in public cloud, on-prem, wherever we want to run it. Second option, we developed a managed API where companies can run the inference in the cloud service, and they can send queries and get results. So the foundation is the customization, the training of the model, the adaptation, and secondly, inference. We have multiple options via container or through an API. So this is really exciting area for NVIDIA with different go-to-market capabilities. So H100 is really a game changer from a performance perspective when we run LLMs. So you can see here time to train in multiple model sizes, like 70 billion, 175 billion, up to 1 trillion parameters. So we can see that it's scaled much better than A100 because of the networking capabilities in InfiniBand, and because of the new architecture and the transformer engine that I mentioned. So we can see here up to 5x speed up for transformer training, and up to 30x speed up for inferencing. So we can serve much more requests, much more users using H100. So really the message here that H100 was designed ground up for transformers and for serving LLMs. So the first building block that actually exposed those capabilities is DGX H100. This is the new supercomputer. So we can run the training process on the DGX H100. We can build what we call base pod, whereas we take few multiple DGXs with the fast networking, like InfiniBand, and we can go up to a superpod. So this is the hardware perspective from the architecture, and on top of it we have DGX software, where we provide the operating system for the AI data center. We leverage accelerate libraries like RTMA for I/O acceleration, cluster management, job scheduling, workflow management. So we are using a new tool from NVIDIA called NVIDIA Base Command. This is the cluster manager, the job scheduler, and on top of it, we have what we call NVIDIA AI Enterprise, which is the software tools like Nemo Megatron, Rapids, Triton, AI frameworks, and other tools in that domain. So the new thing is that we can also provide the computing capacity, not only on-prem, like we did and we still do, but we also provide it as a service. So you will see more and more NVIDIA developing as a service cloud services, and companies will have the choice to select according to their needs, whether it's on-prem deployment or as a service. But the important thing that it's the same technology, the same architecture, the same tools in a hybrid cloud approach. So this is also something new, exciting, going forward. So in the last years, we focus on accelerating new applications in the data science domain, leveraging tools like Rapids and the integration with Apache Spark 3.0, recommendation systems with the SDK named Merlin. For speech and vision, we use Riva, we use Tau, we use DeepStream for the accelerated pipeline. Triton is really popular for inferencing. Many domains developing their serving environment based on Triton. It's an open source backed by NVIDIA and other companies, other developers. And of course, NLP. Nemo Megatron is the framework for large language models, both for training and inferencing. It's a full workflow. Our goal is to bring NVIDIA AI and specifically our software tools and optimizations to everywhere. And open source is really a great approach, and the ecosystem in the AI domain is leveraging open source tools. But to build your full platform on open source sometimes can be risky from support perspective, compatibility, integration. And for that reason, we built NVIDIA AI Enterprise. It's a full stack, accelerated cloud native software for enterprise AI. So this is how it looks like. On the bottom line, we have the infrastructure, can be cloud, public cloud, private cloud, data center, edge. Then we have the MLOps tools. We have infrastructure optimization libraries, GPU virtualization, GPU operators, all the tools needed for a cloud native environment. And we also provide the data science development and deployment tools, from the AI frameworks to tools like TensorRT and Triton, Nemo Megatron, and other tools. And it's also MLOps ready. So we partnered with leading companies like Run AI, Weights and Biases, Domino Labs, and others. So everything is pre-tested, pre-validated, reducing risk. On top of the platform, we developed application workflows. And application workflows are actually very important because it allows data scientists and developer to shorten the cycle from idea to application, to AI application. So you can see here that we have AI workflows and SDKs for video analytics, conversational AI, cybersecurity, speech AI, recommender, and each AI workflows include the framework, application references, documentation, a full workflow that is customized, and all those tools are part of NVIDIA AI Enterprise. So you get the support, you get the compatibility, lowering the risk to develop those new applications. So the goal with NVIDIA AI workflows is that people that are developing applications in specific domains can use what we do at NVIDIA, leverage our pre-trained models, leverage the workflow, and actually develop applications much faster. So it's not only the model, it's the full workflow. So when we talk about end-to-end workflow, so it starts with pre-trained models, going through AI frameworks like PyTorch, TensorFlow that are optimized. We maintain those workflows and make sure that they run best on the latest GPU architecture. Training tools, inferencing tools like TensorRT. Basically, it's a kind of compiler that take the neural network and optimize it to run on a specific GPU with maximum performance and minimum latency. And then we can deploy those models in Triton, which is basically the leading inference server in the market. It's open source, it's cloud native. You can use Kubernetes for auto scaling, and that is really important topic for companies that focus on large scale inference. Triton is something that you should have a look. So all our software is stored in what we call NGC. It's a registry. It's a software catalog that every data scientist, every developer, every researcher can access, and you can download from NGC the AI frameworks like PyTorch, TensorFlow in a Docker image, which is optimized. You can also download AI toolkits that NVIDIA developed, like TensorRT, Triton, Tau, and other tools. You can also download pre-trained models, state-of-the-art accuracy, model scripts, documentation, and other capabilities. So NGC is really the place that we store all the software elements, hundreds of Docker images, fully optimized to run on the GPU platform. I mentioned pre-trained models, so we have tens of pre-trained models. We started with vision, different backbones for classifications, and then object detection, segmentation, and we even train models for specific tasks like people detection, vehicle identification, facial recognitions, and other capabilities. But lately we added also speech capabilities, language translation, and other models in variety of areas. So this is very important. Production quality. Every model has its own resume. We tell you on what we trained the model, how we train the model. You can customize. You can do transfer learning and fine tuning. And really, the tool that make it easy is Tau, NVIDIA Tau. It's a toolkit that you can basically bring your own model weights in an X format, or you can choose from NVIDIA library. As I mentioned, we have tens of pre-trained models. Then we have a CLI that allows developers to retrain the model on a real data or synthetic data. And then the beauty that the customized, so the custom model, the custom production model is already optimized for inference. So it comes in a TensorRT format. You can choose if you want to run it on in8. We do all the precision calibration, pruning, all the needed things for inferencing in a high throughput. And then it's ready to be deployed in DeepStream if it's video analytics, or Riva if it's speech, or Triton if it's a general model. So it's really what we call fast track AI development, from using pre-trained model to transfer learning and fine tuning in a zero code fashion, low code zero code fashion, and then deploy optimized in one of the AI workflows like DeepStream, Riva, or Triton. So few words on Triton. Triton was really improved in the last years. It supports multiple backends like TensorFlow, PyTorch, Python, TensorRT, Rapids. It runs on every GPU generation. Ampere, Volta, Turing. It's also can run on a CPU for inference, x86 or ARM. It has all the needed capabilities for large-scale inference, like dynamic batching. We have a model analyzer that allows the developer, the MLOps engineer, to put constraint like latency, throughput, memory, and then the model analyzer will tell us what is the best config from a batch size, how many copies of the model should we run on a GPU. So all the things that are important for large-scale inference. So really, this is really Triton, and we have a container in NGC. You can just download it, run it on a GPU machine, and start testing your inference needs. So to summarize, so NVIDIA Enterprise is a cloud-native software suite, end-to-end for production AI. It comes included with every DGX system. It's also part of H100. So if you are using H100 hardware, NVIDIA Enterprise is included. And if you want to run NVIDIA AI in the cloud, we have a software subscription. So basically it can run everywhere. What are the next steps? How to learn more? So one thing that I want to highlight is Launchpad. Launchpad is a hands-on lab. It's a testing environment for proof of concepts, for POC. It's free. You can submit a request. We have tens of pre-installed labs on multiple domains like synthetic data generation, image classification, natural language processing. We have labs with Triton, with Riva. We have labs with tools like OpenShift and Tanzu and vSphere and public cloud. So it's really very important if you want to test NVIDIA software, NVIDIA hardware. So Launchpad is a great place to start. And of course, GTC. GTC is something that data scientists and developers and researchers in the AI ecosystem don't want to miss, especially this year going to be extremely interesting, where we talk about large language models and generative AI and the metaverse. Those are the highlights. And of course, it's a digital conference. It's a free registration, and it's going to happen in March 20 to 23. And I want to highlight Jensen keynote. The Jensen keynote is in March 21. It's going to be extremely interesting. I already got some early access to the things that we're going to talk about. I think all of you should be there. And we are going to highlight many sessions on LLM and generative AI this year. So you can see that you have sessions like generative AI, demystify, how to train large language model, techniques like data parallelism, model parallelism that are needed, AI applications. So really encourage you to register to GTC. Keynote is #1, followed by hundreds of on-demand sessions. You can see it later. You can see it live. So it's really great to be up to date on the latest announcement. So with that, I want to thank Uri and the team, and wish you great sessions after me.